Hello everyone. Today let's discuss about the convex hull algorithm with Graham scan. So first let's discuss what does why the algorithm is used and where it is completely useful. So basically the algorithm is used to find the smallest convex polygon so that can enclose a set of points in a 2D plane. Again I'm telling this algorithm is used to find the smallest convex polygon that can enclose a set of points in a 2D plane. So this is very helpful in computational geometry, pattern recognition, as well as geographic information systems, nothing but GIS. So now let's discuss the approach step by step. So first step is we will sort the points based on their x coordinates and y coordinates for ties, right? So first what we will do, we will sort the points based on x coordinates and y coordinates for ties. X coordinates and y coordinates for this one. I'll just mention this one and this. Y for ties, right? So first we will sort the points based on their coordinates, based on their x coordinates and y coordinates for ties. So after doing this, we will build the lower hull. So we will be building first lower hull. I'll just write LH, nothing but lower hull by processing the sorted points. So we'll be building the lower hull by processing the sorted points. For next step is we will be building the upper hull. So I'll just write here, we will be building the upper hull here in reverse order. So this one is very important. We'll be building the upper hull in reverse order, nothing but I'll just write RO here. And the final step of this algorithm will be, we will concatenate lower and upper this one hull. Concatenate lower hull, and for concatenation I'll just use plus, and upper hull. So we'll finally concatenate the lower and upper hulls to get the full convex hull. To get the full convex hull, we will be concatenating lower hull and the upper hull, right? So this is what we'll be doing. First thing is the time complexity of this one will be big of n log n, because we'll be sorting the points, right? So that that leads to the time complexity big of n log n, and the overall space complexity would be big of n. Why? We will be storing the hull points only, so the overall space complexity would be big of n. So let's try writing the code and let's understand that one with the simple example. So I'll just write here, sorry, this has to be, let me consider function. Let me give convex hull with this one points. Also initially we have to sort, right? As we have discussed, this one will be points dot sort a comma b, and based on the coordinates this will be a of 0 minus b of 0 ascending order, or a of 1 x and y coordinates, a of 1 minus b of 1. So a and b we are considering, a and b considering here, we are considering here. So a and b coordinates we can take. So here after this one, I'll just make use of the helper function to calculate the cross product of the vectors, nothing but OA and OB. Why we are making use of the helper function? Basically, it will help determining the concatenation of turn, left or right. Sorry, not the concatenation, orientation of the turn, left or right. So I can just write in this way. So here it will be function cross of, I'll just consider O, A, B here. So I'll just return here a of 0 minus O of 0 into B of 1 minus O of 1. This is one thing. Finally, minus A of 1 minus O of 1. Finally, this will be into B of 0 minus O of 0. So I hope this is clear. So after this, what we'll be doing, as we had discussed in the step 2, we'll be building the lower hull. So third step will be, we'll build the lower hull. Second step. Third step will be, we'll build the upper hull using the reverse order, in the reverse order. And then finally, we'll concatenate both lower hull and upper hull, right? So second step, let's build the lower hull first. So I'll just give here const lower. I'll just set this one to empty array. So after initialization, let's go for the iteration. I'll just consider const p of points here. While the last 2 points and the current point make a non-left turn, then we will move the last point. So I can just write in this way. Just make use of the while. So length of the lower, if it is greater than or equal to 2, and cross, I have already considered cross function, right? Cross of lower within the array, length of the lower minus, this has to be minus 3, not minus 1. So this is fine. And also here, what we'll do, again, lower within the array, length of the lower, minus 1 this time. So we have already considered 2. This has to be previous one, nothing but minus 1 here. Minus 1 after, we have to consider p as well, right? Individual point, nothing but individual point of, we have considered const p of points, right? Individual point. So this one, if it is less than or equal to 0, then we will remove the last point from the lower hull. So to remove the last point, I'll just make use of the pop. After that, we will add the current point to the lower hull at the end, right? So I'll just be making use of the push here. This one will be lower dot push of p, individual points, right? So this is fine. This is, we have built the lower hull. Next step is, we have to build the upper hull, right? So first what we will do, we will declare the array to store the upper hull points. So I'll just give here const upper equals, this is clear. Next, after the initialization, let's go for the iteration. This has to be in the reverse order. So we have to build this one and build the upper hull in the reverse order as we had discussed in the approach. Here I'll just consider points dot length minus 1 and I greater than or equal to 0. So let me decrement I. Your first thing is, I'll consider p to iterated value of the points. So after doing this one, we'll follow the similar logic for as we had done in the lower hull, right? So let me copy this one itself from here to here and make the necessary changes. So here, let me come here. By lower, instead of lower here, this has to be upper dot length. If it is greater than or equal to 2, then here also across it will be upper. Oh, here again dot length minus 2 and also length minus 1 less than or equal to 0. Here let's consider upper. Here also let's consider upper dot length minus 1 comma p. If it is less than or equal to 0, we will just pop here. So we are just doing this one in the reverse order. Here we are for the lower, we didn't do in the reverse order. We did it correct order, right? So here, this one, we are building the upper hull in the reverse order. So this has to be upper instead of lower. Finally, we have to push, right? This one will be upper as well. So I'll just remove this one. So I took extra one bracket, I think. So this is fine. Finally, after this, after building the upper hull, we have to concatenate, right? So we have to, first we will remove the last point of the each half because it is repeated at the beginning of the other half. So for removing, I'll just make use of this one, pop, and this has to be upper and lower as well, right? So I'll just consider this one, pop itself. So finally, we concatenate lower and upper hull to get the full convex hull. So I can just write in this way, a return lower dot. I'll just make use of concat. You can just make use of the plus as well, right? For concatenating, I'll just give lower dot concat of upper. So I'll just give like this. So I hope this is clear. This is for the code. Next, let's try this one. Let's try understanding this one with the example. So here, let me consider points first. Here, let me give within the array. The first one will be, let me give 0, 0. And second one will be 1, 1. Let me give 2, 2. So just give me a second here. The next one I'll just consider 2, 0. 3, 1. And 3, 3. Finally, 0, 3. And I hope after this, considering the points, we have to get the result, right? So I'll just consider this variable name, results itself, result answer, anything is fine. So I have given the function name, convex hull of what is the parameter points, right? So I'll just consider the points here. So finally, let's print the result in this way. I'll just make use of let's log this one, console log of, I'll just give here, in my case, convex hull points. We can just write in this way. So let me make use of JSON dot stringify. Here S has to be kept, this one small. Just give me a second here. Stringify of result, right? So we'll just get this one in the string. So I'll just be making use of the JSON dot stringify of result. So I hope this is clear, right? This is correct. So yeah, this is fine. Finally, let me hit the run. Let's see. So here the output has to be 0, 0, 0, 3, 3, 3, 3, 1 and 2, 0. So let's see whether this works or not. Yeah, here it is 0, 0, 0. It has to be, just give me a second. I think this is wrong. We have to get 00 points 0, 0, 0, 3, 3, 3, 3, 1 and finally 2 and 0. So the answer that we are getting is correct, but we are not getting in the order, right? So just give me a second here. So yeah, basically this is correct. We are not going in any order, right? So basically the answer that we got is correct. What it represents here, it represents the vertices of the convex hull enclosing the set of points in a counterclockwise order. So here we are getting the smallest convex polygon, right? That can be, that can encapsulate all the given points. So this solution is correct. So I got confused here. So yeah, this is it for the algorithm. So next we'll be discussing about the future algorithms, right? So this is it. Thanks for watching, guys.